So today, you can see we actually have a couple of learning goals here. I can use proportions to solve problems involving geometric figures. So kind of on the front here, the first thing we're going to do is we're going to review some geometry, make sure that we understand some of the geometry skills and labels and everything that we need to make sure we remember how to do, because you should have come to me with those skills. And then I can use proportions and similar figures to measure objects indirectly. So we're going to be talking about similar figures when we're reviewing our geometry here. So I have a little table here to help us be reminded to review what the different symbols mean in geometry. What words are they actually standing for? So when we have capital X, a capital Y with a little line over it, we would read that segment XY. Okay? We would make sure we read that properly. So just take a quick look through that table. I'm not going to read through all of those. Are any of those unfamiliar to you and you need to ask any questions about? Anybody have any questions? So most often where the mistake is made, where students don't recognize the difference between, is this one. When there is the line over it, it means we're referring to the line segment XY. Whereas here, when we have that capital X, capital Y, but no line over it, now we're still talking about a line segment, but now we're talking about its length. So now we're saying, what's the length of line segment XY? Okay, so we have to make sure that we know the difference between those two things, okay? So, no other questions though? Okay, what's another symbol that uses that little squiggly like that? Is there another math symbol that uses something like that?
Equal sign.
Yeah, the approximately equal to sign, but that has two of those, doesn't it? So when we have two of them, it means approximately equal to, and when there's just one squiggle, it means is similar to. So it's saying those, when it's between two figures, names, it is saying those guys are similar to each other. So in this particular one, I want you to start by writing, I want you to do 1 through 3, answer each question. Write triangle ABC in symbols, and then you have 2 more to do, and the other 2 are to do in words. I won't make you do the number parts in words, but everything else you should be able to use words for. Okay, after you're done, you can check yourself out and see how you did. Would you be able to read those properly? Can anybody tell me what those capital letters come from? Where did they get those when they were naming the triangles? So in fact, these triangles we can refer to up here. So where did they get the letter names in the triangle? Where do they come from? So triangle ABC, why do they call it triangle ABC? And when we look at that name for it, what should we be able to assume then if they call it triangle ABC? Austin?
It's got 3 angles that are labeled ABC.
Yeah, it's got three angles, and at that vertex of that angle, so actually those points are at the vertex, we call them. So we have triangle ABC, we have vertex A, we have vertex B, we have vertex C, okay? And in the other one, we have the same thing. We have three angles, so the vertex of each of those angles, the point that is at that vertex, its letter name becomes part of the name of the triangle. So let's write here that we have triangle ABC similar to triangle XYZ. Now, it doesn't matter. Triangle XYZ could come first in the relationship. Triangle XYZ is also similar to triangle ABC. It's kind of like the equal sign. They can trade sides of this similarity relationship. Okay, so let's go now down here. Anybody have any questions about 1 through 3 at all? So is this prior information? We know this before we got here, right? Okay. So use the information given in the symbols below to label the diagram shown above. Okay, so what does this say right here? What does this tell us? Okay, the measure of angle X is 38 degrees. So we'll go up here to angle X, which is the angle when it has a vertex of X, and we say in there, we can say that that is 38 degrees. And then let's jump down here to the next one right below it. What does that say? What does this one say? What does that say? Right there. Yeah, the length of segment XY is equal to 18 centimeters. So we go up and we find segment XY, and we say, okay, its length then is 18 centimeters. Okay, you go label those other 4 pieces that we have left to do. Label the others also, please. And see if you agree with me. Now notice sometimes it's a little hard to, the space isn't all that big, and so sometimes it's almost better to write the measure of the angle outside the angle and then show a little, showing, okay, this is what I am referring to by putting my little loop there. That is, I can count on that angle in that corner to be equal to 93 degrees. Okay, so now once we have these 2 triangles that we say are similar to each other, we know this much about them. We'll see with the given information that we have, can we supply some other information? So let's go down here and see if we can supply some other information. Corresponding angles of similar triangles have the same measure. Why is that? What's the definition of similar figures that makes them have the same angle measures? That corresponding angles are equal. What do those equal angles create? Or tell me, what's the definition of similar figures, maybe? We don't know the definition of similar figures. Maybe we need to look that one up. Maybe that's in our algebra book. No one knows what similar figures are? Austin?
Something that's the same, but just a different size.
Okay. So something that's the same. So in other words, it's the same what? Shape. It's the same shape, but the different size. One might be smaller than the other, right? So similar figures have the same shape, but they can be different sizes. So why then would the angle measures be the same? Why would corresponding angle measures in similar figures be the same? Or in other words, what creates the same shape? Same angles. Same angles would create same shapes, wouldn't they? if we can match up all the angles, their corresponding angles are equal, that's going to create the same shape. So considering that then, if corresponding angles have similar triangles, have the same measure, what is the measure of angle Z? So we have to find, what does corresponding mean? Anybody know then, okay, which angle is angle Z correspond with? Angle C? So then what, how did we decide that it corresponds with angle C? It's in the same relative position in the triangle. Even if they're not turned, are these two turned the same way? Are they, no, they're not matched up. One's rotated a different direction. So we are saying that angle Z up here, we're saying that this angle right here corresponds with angle C, which is the one right here. And so what would the measure of angle Z be then if these are similar figures? 49 degrees. We can count on that this is also a 49-degree angle. What if we didn't have the figures here? What if those figures weren't up there for us to look at, but we were told that the measure of angle Z was, or the angle of measure C, excuse me, the measure of angle C was 49 degrees. How would we be able to say to somebody with confidence that the measure of angle Z then is also 49 degrees? Anybody know how we'd be able to say that? Shay? Okay, but I don't know anything but the 38 degrees in that one. That's the only thing I know in that triangle that has Z in it. So how am I going to figure out that Z is 49 degrees without knowing two angle measures? So again, I don't have the picture. I just know that triangle ABC is similar to triangle XYZ, and I have been told that the measure of angle C is 49 degrees, and the question is, what's the measure of angle Z? Yeah.
They're in the same spot in the.
But remember, I don't have the picture. Oh,
Well, not in the picture, in the similar to.
Oh, in their names, they're in the same location. Yes, that's a place we can look also. C is in the third position, so the corresponding angle would also be in the third position. So if we did not have the picture, we could use that to help us out, right? Okay. So the measure of angle Z then is what? 49 degrees, okay. And then, what's the measure of angle A? Which angle does it correspond with, first of all? X. A, B, C, X, Y, Z. So it corresponds with measure angle X. Do we know angle X? What is it? 38 degrees. So we're going to say that the measure of angle A then has to be 38 degrees also, because it is the corresponding angle. Okay, let's see, do those three, now that we know those three, do they add up to 180?
Yeah.
Do they? So 49 plus 38, what's that? 49 plus 38? Close, but not quite that. Isn't it
87.
87? Okay, and then is 87 plus 93, what's that?
180.
180. So yeah, so it seems legit that we could have those angle measures, doesn't it? Questions? Because it's important that we understand the relationship between similar figures. Because now we're going to start applying proportions to similar figures. So, write a proportion relating, what does this say again? What's that say?
AB.
Oh, what about AB?
Oh,
Length of
Length of AB,
Length of BC.
length of BC,
Length of XY.
length of XY, length of YZ. We're supposed to compare. So here's the deal. In similar figures, ratios of corresponding sides are the same. So if you set up a ratio of corresponding sides, it should be equal to any other ratio of corresponding sides. We should have 3 different sets of corresponding sides in a triangle, right? So any 2 of those 3 should be equal to each other. So it doesn't matter which 2 you put together, in a proportion, they should be equal to each other. So they want us to use these 4 sides. These four side lengths. So how can we compare them? Shay, what's one way?
AB over BC is equal to XY over YZ.
So like that? Is that a good comparison? So the comparison between the triangles is not happening within the ratio, it's happening where? Across the way, in the numerators. So side AB corresponds with side XY. Side BC corresponds with side YZ. If you put the corresponding sides in the numerators, then the corresponding sides would go in the denominator. The other set of corresponding sides would go in the denominator. Or, give me one where we show the ratio of corresponding sides equal to another ratio of corresponding sides. Devin, how would that look?
AB over 10 centimeters.
No, don't give me any numbers yet. I just want these symbols. AB corresponds with what side in triangle XYZ? XY. And the other one from the triangle ABC, since we're using triangle ABC in the numerator of one, we have to use triangle ABC in the numerator of the other. So BC corresponds with YZ. Those are ratios of corresponding sides. But both of those proportions should work for solving. Now use one of those proportions and solve for AB. So we're looking for the length of AB. So I'm going to use the second one. So I'm just going to write it down, because this is what I'm going to expect you to do in your homework. I'm going to expect to see what did it look like with the line segment names, showing it so that we can say, what was I comparing here? And we're looking for AB, so we're going to call ABX because we don't know what AB is. What's the length of XY? Well, 18, okay. And we need the length of BC. Do we know the length of BC? 10 centimeters, okay. And we need the length of YZ. Do we know the length of YZ? 15 centimeters, okay. Well, we have enough information then, don't we, to solve that proportion. Let's do cross products. Do we all get 12?
Yeah.
Okay, and those are 12 centimeters. But you know what? We weren't solving for X. What were we really solving for? Length of AB. So AB, length AB equals 12 centimeters. There's our final answer. That's what we were looking for. X stood in temporarily for the length of AB. So questions, because that's what we're going to now practice on the back side. Okay, go to the back side. Let's take a look at it. The first one we're going to do back there. If triangle ABC is similar to triangle DEF, then here's what we can count on. The measure of angle A in this would be equal to the measure of angle. The measure of angle A would be equal to the measure of angle D. Yeah. The measure of angle B would be equal to the measure of angle E. And the measure of angle C would be equal to the measure of angle F. So in other words, we want to make sure that we understand the relationship between these two triangles. Let's set up some corresponding sides now. Side AB would correspond with, the length of AB would correspond with the length of DE, because here's AB, so we need DE. The length of BC would correspond with the length of EF, because BC are the last two letters, so we need the last two here, so EF. And last but not least, we also have another side left in triangle ABC. What is it? AC. We haven't used up side AC. We used AB, we've used up BC, but we haven't used up AC. So AC corresponds with DF. AC, DF. So we have now set up, this is not a proportion, this is saying every set of ratios, every ratio of corresponding sides, they are all the same. They are all equal to each other. So it would be like saying 2 equals 2 equals 2. When you set up the ratio and divide it out, you can count on those being the same. Okay, so let's go to this one right here. MNOP is similar to WXYZ. What kind of a figure is that? Maybe. Maybe. Square and rectangle I've heard so far. Those are maybes. For sure it's a what?
Quadrilateral.
Quadrilateral. Or at best we could say it's a quadrilateral. We don't have a picture, do we? We don't know if it's a rectangle, we don't know if it's a square, but we know it's a 4-sided figure, don't we? Because it has 4, what do we call these again?
Vertex.
Vertices, yeah, vertex. One is called a vertex, the plural is vertices. So we have this quadrilateral, similar to another quadrilateral, and they're saying if length NO is 2 centimeters, and length XY is 2 8/10 centimeters, and length ZW is 7 centimeters, find the length of PM. So we need to set up a proportion now. We're going to need to use these guys in our setup. So let's just start. Length NO, what length does that correspond with from the other quadrilateral? XY, yeah, the one in the middle. And so we've used up our first two, that's good. We need a ZW. So ZW, should that go upstairs? No, because we have to keep the relationship, so we have to be really careful about that. We have to keep the relationship. So the quadrilateral MNOP is in the numerator in the other one, so it has to be in the numerator in this one. So it's the PM that we need to find. That comes from the first quadrilateral. Does PM correspond with ZW, the one we have left?
Yes.
So PM, ZW, yep, we're good. Okay, here's our relationship setup. Ratio of corresponding sides. Anybody have questions about our setup first? Because now we're going to start subbing in. We're going to put 2 in for length of line segment NO. We're going to put in 2.8 for length of line segment XY. We don't know PM, so we'll call it X. And length ZW is 7. So now we can solve that proportion. We get that one solved. How long is line segment PM? I almost did what my students do all the time, divide by X. What'd you get?
5 centimeters.
5 centimeters. What did I do wrong here?
You
multiply.
multiply 2.8 times.
Yeah, I took 2 times 8, didn't I? Crazy. Where does that thought come from, huh? Ooh, not even as high as multiplication was. So, okay, 2 8/10, 2 8/10, divided by 2 8/10, and I should be dividing. Okay, so what is the answer? 5. Thank you. Okay, x equals 5. Okay, so is that our answer? Are we done? No, the length of PM is what they wanted. Length PM is equal to
5 centimeters.
5 centimeters. Okay, there's our final answer. Okay, it looks like we need our book for the next one. If you want to start getting that out. Page 70 in your books. No questions though on that? Straighten me out. Page 70, we're going to go do our other learning goal says we can use similar figures and proportions to measure objects indirectly. So you guys have actually already been doing this, those of you who did the shadow and tree problem in the yellow packets. Anybody do that problem in the yellow packet? A couple of you did, okay. That was indirect measurement going on there, okay. So let's look at 2B where it says, a woman who is 5.5 feet tall casts a shadow 3.5 feet long. At the same time, and that's important because we gotta be doing the measuring when the sun is at the same spot in the sky. We're talking about shadows, right? Because our shadows different lengths at different times of the day. Yeah, they are, aren't they? So at the same time, a building casts a shadow 28 feet long. Write and solve a proportion to find the height of the building. Now I find drawing pictures in these the most helpful. So I would do this. I would say, okay, here is my woman. She's just a stick. Here is her shadow. So how tall is this woman?
5'5".
5.5, not 5 foot 5 inches. She's 5.5 feet, right? Okay, 5.5 feet. And then how long is her shadow? Oh, her shadow's shorter than she is, so I guess I should try and make it look a little bit better anyway. That's 3.5. And then we would connect where the sun is, the height of, at the top of her head to the end of her shadow, and we would create a triangle here. Because this angle measure is going to be the same as the one we created the other one because it's the same time of the day. The sun is at the same location. And what's happening down here? What kind of an angle is down in this corner? A right angle. So this is a right angle, and that one is the one created by the sun. Now let's do the building. Here's my building. And how tall is the building? We don't know. It's X. Okay. So that's X feet. And how long is its shadow?
28 feet.
28 feet. So again, it's the same time of the day. So the sun is creating the same angle right there. The building would make a right angle with the ground, right? So these two triangles are similar to each other. So we could say similar triangles here. So now we should be able to set up a ratio, a proportion with ratios of corresponding sides. So give me an example of one we could do. Devin?
5.5 feet over X equals 3.5 feet over 28 feet.
Okay, so here we're comparing the height of the girl to the height of the building. Shadow of the girl to shadow of the building. Good comparisons? Okay, that would be one way we could do it. So this is corresponding sides. So let's go ahead and do it because we're running out of time here. We could show if there's other ways to do it, but we're going to get our proportions solved. So you go ahead and do it, and I'll try and do it right this time. Get X to equal the same thing I did, 44, okay. So what was the question of this, in this problem?
How tall the building was?
Okay, so we would say the building is
44.
44 feet tall. 44 feet tall. We're writing a sentence here. Isn't that cool? Okay. Building is 44 feet tall. Does that seem reasonable?
Yeah.
Because why again?
Because the building has to be taller than the shadow.
The building has to be taller than the shadow, and 44 is greater than 28, isn't it? So it seems like a reasonable answer. Okay. So, question. Okay, then make sure you write down the assignment carefully, which problems you are to do. And you got the assignment written down, or you can make sure you get it written down. Anybody else who needed their worksheet for one last, and we'll finish up with something? Everybody's wishes are back in the basket.
Yep, you don't need your quiz to do it, though. You already got the numbers on there, so just go and start figuring out what needs to be done, okay? So, the next column is a totaling column, Josh, so what should you do in the totaling column?